All right, today we are going to continue discussing acids and bases. So, the objectives for today's lesson, we will describe pH. We will predict whether a substance is an acid or a base based on its pH. We will also explain the relationship between the hydronium concentration and the pH. Right now, self ionization of water. Water, you already know it is a molecular compound. It is H2O. So you would tell me that water as a molecular compound does not ionize. Okay? But it is found for every 1 mole of water, you will have a little bit of that water that will ionize into H plus and OH minus. Another way you can write it, you can write down water plus water equilibrium. I don't put one arrow, I put the equilibrium sign because it does not go to completion. Only a little bit will dissociate into or will ionize into hydronium ion and hydroxide ion. Those two equations are the same. They are the same. Okay? So, when I say a little bit, how much of it will ionize? For every 1 mole of water, for every 10 millions, 1 out of 10 millions will ionize. Which is what? It is 1 times 10 to the negative 7 will ionize a little bit. Because of that, we can write the ion product constant for water. It is K. And because it is water, we will put the subscript W. If you remember, I told you when we discussed equilibrium that we have many different types of K. So this is another one. This is called the ion product constant for water. It is KW. W for water. Equal. If I look at this equation right here, KW equal, it is H plus or hydronium times OH minus, the concentration of OH minus over the water, but because water is a liquid, I do not put it. So I need for you to make sure you write KW equal concentration of hydrogen ion times the concentration of hydroxide ion. And this is a constant at room temperature. That constant, if I tell you the concentration of hydrogen is 1 times 10 to the negative 7, hydroxide 1 times 10 to the negative 7 for a neutral solution, then that KW equal 1.0 times 10 to the negative 14. I need for you to know that constant, you will be using it a lot. So write down KW, the ion product constant of water equal 1.0 times 10 to the negative 14 at room temperature. So we are going to use that constant. Calculate pH. pH, what does that mean? pH. It is from French, it is le pouvoir d'hydrogène. Le pouvoir d'hydrogène. It's not important. Okay? Le pouvoir. Don't worry about this. D'hydrogène. This is hydrogène. That's why you write lowercase p. You have to write capital H because it is the symbol for hydrogen. What does that mean? The formula for pH, what on that formula you need to know it, equal the negative log of the concentration of hydrogen ion. So if you have a very cheap calculator that has no log, then you will have problems for this unit. We will be using the log base 10. Negative log of the concentration of hydrogen. Okay, remember we said whenever you have hydrogen, you can put hydronium also, which is the same thing as negative log of the concentration of hydronium ion. In other words, if you have a number, let's say 10 to the negative something, that something is the pH. 10 to the negative something, that something is the pH. And then the P is not done only for the H. We can have POH, PW, P happy face, P bananas. Whatever you have P of something, that something will be the power. Okay, so POH, what done POH equal what? The negative log of the concentration of OH minus. PKW equal the negative log of the concentration of KW. P whatever equal the negative log of that concentration. Okay, let's move on. Now, let's compare concentration of hydronium ion or hydrogen ion with pH. I need for you to look at this carefully. Hydronium ion. If the hydronium ion concentration is greater than the concentration of hydroxide ion, the solution is acidic. You have more hydrogen ion than hydroxide ion. If the concentration of hydronium ion equal the concentration of hydroxide ion, the solution is neutral. If the concentration of hydroxide ion is greater than the concentration of hydronium ion, the solution is basic. Okay, now let me repeat with pH. No, we are not at pH yet, but I can say it with pH. Let's start again. If the concentration of hydronium ion is greater than the concentration of hydroxide ion, the solution is acidic. Therefore, the pH is less than 7. If the concentration of hydronium ion equal the concentration of hydroxide ion, the solution is neutral. The pH is 7. If the concentration of hydroxide ion is greater than the concentration of hydronium ion, the solution is basic. Therefore, the pH is greater than 7. All right. So let me show you. For a neutral solution, the concentration of hydrogen ion equal the concentration of hydroxide ion equal 1 times 10 to the negative 7. Okay, now this is what I already discussed in the last page. If for any solution that is less than, if the pH is the concentration of hydrogen ion is greater than 10 to the negative 7, the solution is acidic. The pH is less than 7. I need for you to check. The lower the pH, the more acidic is the solution. If the solution has a pH of 1, it is more acidic than a solution that has a pH of 5. The higher the pH, okay, the more basic is that solution, and the stronger is that base. All right, make sure you see the relationship between those two. Colors are slightly acidic, so they tell you it is acidic. If the hydrogen ion concentration is 1 times 10 to the negative 5, is the solution acidic, basic, or neutral? What you need to ask yourself is that concentration greater than 1 times 10 to the negative 7, or is it less than 1 times 10 to the negative 7? It is greater. If the hydrogen ion concentration is greater than 1 times 10 to the negative 7, therefore the solution is acidic. It is acidic. And here's the question. And they ask you to find the concentration of OH minus. How do we find the concentration of OH minus? We use the formula KW, remember that? Equal concentration of hydrogen ion times the concentration of hydroxide ion equal 1 times 10 to the negative 14. The product of those two equal 1 times 10 to the negative 14. Therefore, I can just plug the numbers now. I have, 1 times 10 to the negative 14, 1 times 10 to the negative 14 equal, the hydrogen ion is 1.0 times 10 to the negative 5 times my OH minus. Therefore, the concentration of OH minus equal 1.0 times 10 to the negative 14 divided by 1.0 times 10 to the negative 5. Therefore, my concentration of OH minus equal what? 1.0 times 10 to the negative 9. So using the relationship, the formula KW equal H plus times OH minus, you should be able to solve from one to another. Okay, here's another one. What is the pH? They ask for pH, question mark, of a solution with a hydrogen ion concentration of. They give me the bracket H plus. They give it to me. And they ask me for pH. Lowercase p, capital H equal. What formula do I use? The negative log. Negative, you can pull out your calculators for me, please. Negative log of the concentration of H plus. Therefore, pH equal the negative log of 4.2, negative log of 4.2 times 10 to the negative 10. Okay, therefore pH equal what? 9.38. Guess what? I have bad news for you. If you think significant figure was bad, what I'm going to say now will be worse. When you do pH, you count the significant figure from the concentration, which is 2. This is the number of decimal places in your pH. Remember, we're dealing with log. Okay, let me repeat. You don't do significant figure for pH. You check the decimal places. So you check how many significant figure in the concentration. That's the number of decimal places in your pH. So things get a little bit more confusing now. Okay, so is that solution acidic, basic, or neutral? It is basic, 9.3. Okay, let's move on. We set next page. Is that the next page? Yes, it is the next page. Okay, checking on the time. I have short time. The pH of an unknown solution is this. They gave me the pH this time. And they asked me for the hydrogen ion concentration. So we are going backward now. So on your calculator, you need to do the second log negative pH to find the concentration. And if you look at your calculator, is that right? Second, yes it is. Second, log negative, not minus, your pH will give you the concentration. .47 10 to the negative 10. Now we need to use negative 7. We need to use a unit for our concentration. No unit for pH, but we need a unit for our concentration. Negative what? 7. It is molar. Big M. Big M. Now let me use my magic mirror to see if you are right. Okay, it is 4.5 times 10 to the negative 7 mole. So this is the pH that has 2 decimal places. Your concentration should have 2 significant figures. Okay, let's move on. What is the pH? Oh, I have 1 minute. Let's do this and I will stop. Okay, unfortunately I will stop. What is the pH of a solution if the hydroxide ion concentration is 4.0 times 10 to the negative 11? They give me hydroxide, but they ask me for pH. This is OH minus. They ask me for pH. So I need to find the concentration of H plus. H plus equal 1.0 times 10 to the negative 14 divided by my OH minus. Okay, what is that answer? So this is my H plus. Okay, now, okay, what is 1 times 10 to the negative 14 divided by 4.0 times 10 to the negative 11? 2.5 times 10 to the negative 4. And that's what you use here, the negative log of 2.5 times 10 to the negative 4. The answer is? The answer is 3.6. Bye-bye, I'll see you next time.